What was that? Why this switch loud? Very welcome, everybody. Some students that just joined us. So we are going to start another topic, which is about batteries. This topic is my favorite topic. I don't know how many other students are interested learning about batteries and energy storage. As I mentioned earlier, we are going to start with the fundamental requirements about batteries, introducing you different type of batteries inside the market. And gradually we start learning how to design a battery. This is the focus for this topic. It may take like 2-3 sessions to finish it because it's both battery and energy storage. But definitely at the end of this topic, you are going to have a good understanding of what's the difference between primary batteries, secondary batteries, reserve batteries, and of course some of the materials, which is more focused on the chemical part of the batteries in order to pick the right one based on the application. So this is very useful, more specifically for automotive application, as you're gonna learn while we are seeing that like everything is moving toward electric vehicle and hybrid electric vehicle. Definitely any engineer out there, regardless of your focus or let's say your major, this is a good opportunity to educate yourself about the energy storage, generally renewable energy design, as it will help you to find a career in any industry, regardless of it is automation, automotive, food industry, I don't know, any industry. Because everybody in every industry, they do have some challenge to deal with, which is like energy storage, right? And energy storage nowadays also we have multiple sources for energy storage, but is there anyone who can name some of the most important one? More specifically, renewable energy. Like what? One of them you can see on my screen, and this is going to be the topic for today, or let's say for this lecture. It is battery. How about solar cells, right? How about wind? These are different sources of energy or sources of electricity out there. So when we say renewable energy, mostly it is focused on those that somehow goes back to the nature, right? Therefore, we have to make sure that we have a good understanding of energy storage in order to be able to save more energy and of course pick the right source of energy for different applications, which will help climate change and all of those side effects in the society and their negative impacts, not only on human life, but definitely on the nature as well, right? So today we are going to start this discussion. First, I'm gonna start with battery charging, discharging of the battery, and later I'm gonna expand the topic and generally talk about energy storage, how to save it, and how many other sources of energies are out there. So let's talk about the fundamental knowledge about the battery. I'm pretty sure every single one of you, every now and then, hear about primary battery or primary energy storage and secondary. When we say primary, simply means those which has a longer history. They are old, and definitely back then the batteries, they were not chargeable. So batteries back then, it was just only one time use. That's why we call them primary type of batteries. So after you use them, after they are discharged, after the first use, then they are garbage, right? But when we say secondary source of the energy or the batteries, including renewable energy, those source of the batteries, they are the one that they are rechargeable. You can use them multiple times. That doesn't mean if you have a rechargeable battery, there is no end of life for them. Definitely, even rechargeable batteries, they do have a life cycle. Simply means they may have like the limitation of for how long you can charge them or you can discharge them. And that simply is a factor of their chemical reaction. That's why they do have limitation for the number of the cycle. For example, some of them, they are designed to only be used for 5,000 cycle or like 3,000 cycle, not more than that. And that's another reason that even with your laptops, not only automotive, any devices which is using rechargeable batteries, every now and then you may use another brand new batteries in order to make it fully functional. And the reason behind it is all those chemical reactions. Well, there are lots of factors involved in losing your battery or secondary energy storage. Simply the temperature that you are charging and discharging, right? The environment has direct impact on the speed of chemical reaction within that secondary battery or rechargeable battery. I have already included some like type of the secondary batteries because they can be developed based on the material we are using for their electrode and cathode. And definitely they do have another layer, which in the upcoming slide, I'm going to show you the structure of a secondary battery, which is called electrolyte or separator. So we have, for most of the batteries, we have 3 layers. Why I say most of them? Is there any battery that may have less than 3 layers? Yes. We do have some type of batteries that in their structure, they do have less number of layers in order to become fully functional, right? So, for example, in secondary batteries or rechargeable batteries, one of the most important and maybe the well-known common type of rechargeable batteries are lithium-ion batteries. They do have different applications, including like your cell phone, laptop, and of course, even for automotive application. So the size of the battery could define, it could be used for high voltage or low voltage, but still the material could be lithium. Lithium can be combined with another material. It's not always lithium, like for example, we have different type of material for the other layer, but still lithium ion cell, we call them lithium ion cell, but the type of the material inside may be different material, right? We have another one, which is lead acid. Lead acid is very common for automotive application, not for handheld devices. I'm going to explain the detail of lead acid shortly, but still in here, I'm going to summarize. Why is that? Why we do not use lead acid for example, your cell phone, for such a small device? The reason behind it is lead acid is a type of batteries that is able to just go through the chemical reaction super fast and definitely release a lot of energy. And since this is the process inside it in terms of chemical reaction, it is better to be used for only those applications that we need less discharge, less number of discharge, let's say per day. Some devices such as your cell phone, you are using it maybe all day, every day, right? And therefore, you may need to charge it multiple times. Lead acid batteries, because of the type of the material they do have, they are not capable of handling multiple charges. Also, they are rechargeable batteries, but they will get damaged. And of course, since they release a lot of energy, they are not the most efficient type of the battery to be used for low voltage or low current application. That's why lithium ion is the most efficient option for the small devices that they are going to be frequently charged and discharged. And many more, this conversation about it, which we are gonna discuss it later. So mostly I'm gonna focus on lithium ion and of course lead acid batteries for today, and we will discuss the other type as well. Another type, which you may heard about it not too often, is called reserve battery. What does it mean when we say reserve? Again, before everything, reserve batteries are a type of primary battery, means they are not rechargeable. Still, you can use them only one type. But the difference, or I would say the main difference between reserve battery and primary battery is about the way that they are designed. Primary batteries, even if you store them, still they are active. And suppose you are storing just regular A-type or double A-type cylindrical batteries, maybe in your drawer at home for a long time. Although they are still inside the package, maybe after a year or maybe sometime, based on what kind of temperature you are storing them, you may go check them and you may see they are bad. You may see some liquid is just coming out of them. They have some leakage, although you never use them, right? Therefore, this type of primary batteries are always active. Even if they are still inside the pack, their chemical reaction is going on, and that's why they do have some self-discharge. Sometimes they are not bad, still they do not have any leakage, anything. They are like in the very functional format. But when you measure them, if you grab your multimeter and measure them, and of course look at maybe the package and see what is the nominal voltage or what was the like let's say maximum voltage that was the expectation, you see the battery has like less than the maximum or the expected voltage, and that's what we call it self-discharge. And self-discharge is a product of chemical reaction inside the battery, and that chemical reaction can speed up if you are storing them in high temperature. Any temperature above maybe 30 or 35, it can damage the battery, right? So, but about the reserve battery, I explained this to say what's the difference between the reserve battery. Reserve battery, they have an option in order to keep them inactive while they are stored, while they are in a storage. Therefore, the potential for them to be destroyed and get bad is less than actual primary battery. Again, I'm going to repeat, reserve battery is like primary battery, or I would say primary battery is non-rechargeable battery. But the only difference in here, these are their chemical is isolated. Therefore, they do not have chemical reaction while they are, let's say, sitting on the desk or in the storage area. Therefore, only when you want to use them, you activate them. That's why we call them reserve battery. Means the charge and discharge will start becoming activated when we want it. Otherwise, they are safe to be stored for a long time. Make sense? What's the difference now? Any questions so far? Next. Some of you already, again, I'm going back to the example of your cell phone or laptop. Not the current versions of cell phone or laptop, maybe older version. If some of you already have some of the older version of the laptop or cell phone that you were able to remove the battery, because nowadays, even in cell phone, even in laptop, any other electronic toys or electronic devices in the market, most of them, the battery is sealed or it's a part of the package, and you have no access to remove them and change them easily unless you are taking it to somebody who's expert to do so for you. But before, or I would say the older version of cell phones and laptop, not even too old, maybe 4 or 5 years ago, is still available. I myself have those laptops and cell phones. So you can open the back of the cell phone, if you can remember. If you open the back of the cell phone, you can remove the battery, and you can easily exchange it in case it is broken and use a brand new one. Same for the laptop. Previous version of the laptop, they had an option to remove the battery in case they are broken and still directly connect it to the outlet and get the power through the wall and let it work fully functional. But recent version of the battery, I would say the laptop, since they are getting thinner and thinner, they have to just seal them in a way. That's not the only reason, but this is one of the reasons. They are sealed to stay safe, to not to be touched, to not to be exposed to many different things which may damage them. But why I'm using this explanation? Because if you had that opportunity to take off the battery from your laptop, you may see it's just one piece. It was not multiple pieces of battery. Therefore, you may think that's only one single cell. But when we are looking at the structure or construction of the battery, we divide them to, I would say, four level of battery. In here, you can see the one that you may see inside your laptop, inside your cell phone, which is called battery cell. But even before this, there is one, we call it single cell. Single cell is the smallest level of battery design. Single cell is when we have only one layer of positive, one layer of electrolyte or separator, and one layer of negative. That's what we call it single cell, because in the design of battery, we always have all of these three layers involved. And some batteries, as I said at the beginning, they are exceptional. They have only two layers, but mostly they have three. But when we say single cell, means I'm creating a battery. Still, they are a battery, but they have only one cathode, one anode, and one electrolyte. But what you see in your devices is not one. We call it a battery cell, but inside this cell, you may have, based on the device that you are using, you may have 10 to hundreds of single cells. And based on the type of the battery, for example, this one, or prismatic batteries, they do have like being folded. Like, for example, they do have a very long sheet of cathode, very long sheet of electrolyte, and a long sheet of like anode, and they have been placed on top of each other with some certain order. And of course, it has to be to the like standards, and then they fold them. And then based on that, either they design or they create or develop like a cylindrical battery, which is like this type of battery, the style is cylindrical, or they have prismatic or different type of batteries. We have coin cell, we have prismatic, we have cylindrical, and so on. But still inside, it might be the very same material, but the way that they fold it or the way they connect the layers of the battery, it might be different because we have different method of creating them. And then if you wanted to level up, if you have a single cell, you can connect many of them, either parallel or series, or a combination of parallel and series. It depends which kind of battery you are designing to create a battery cell. And then if you have battery cell, if you have like so many of them, or maybe even two of them, three of them being connected to positive and negative, you can create a battery module, right? And for automotive application, we are focused on automotive. For automotive application, we have hundreds of this module to be connected in a series or parallel, or a combination of series and parallel, in order to create a battery pack, right? Therefore, when you see a battery, as an expert, you should understand that this is not just one battery. Inside it, if it is just a battery cell, inside it, you may have many layers. If you have a module, inside this module, you may have many of the battery cells. If you have, like, for example, this is the battery pack for Chevrolet, right? If you have like such a pack, we call them pack, when we have many of them, inside this, you have a lot of modules based on how much power or how much energy I'm planning to generate for that certain application. And this is a part of this lecture. At some point, I'm going to teach you how to calculate the required energy for your pack design. And after you calculate it, how to build it, how many number of cells do you need, and how many of them should be in parallel connection, how many of them should be in series connection, right? And definitely the connection method can impact the number of cells, right? Why is that? Who can answer this question? What will happen if I have series connection? Suppose this is one battery. This is positive, negative. What's the difference between series and parallel? Any components, battery or any load, even resistor, whatever component that they do have like connection from both ends, like this, what do we call it? If I'm having like three of them, and if I have connection from both ends, means all of them What kind of connection is this one? Parallel. Yeah, this is parallel connection. But if I'm having like components being connected only from one end like this is what we call it series connection. Now, the most important part is what's the difference between the voltage and current in parallel connection and series connection? Who can answer this one? In here and in here, what would be the difference? If I add, yes. Series current is the same. Voltage is the same, right? So if I'm having parallel connection, means voltage for all of them will remain the same. If the voltage is the same, means current is going to be variable in here. I'm going to have different value of current for them, but still they are supposed to generate, or let's say handle, the same amount of voltage. And in here it is opposite. In here current is like IT, means I total, is equal to, for example, if this is 1, if this is 2, I'm gonna write this with a different, this is important. Also it might seem basic, but it is important. In here, if they are series, and I'm gonna calculate I total, in here I total, if this is number 1 and 2 equals to I1 equals to I2 and so on. And in here is opposite. If I'm calculating V total is equal to, this is 1, 2, and 3, V1, V2 equal to so. But how about I? I is gonna be accumulation, right? I in here is gonna be accumulation of I1, I2, and so on. And here opposite, I'm gonna write it with different color. Here I is equal, voltage is gonna be accumulation. How about that? Make sense? That's the difference. That's why I say it is super important to be expert enough, especially while you are planning to design a huge pack. And since you guys are expert in the field of automotive, you know that the weight of the pack has direct impact on your automotive design. Some of the impacts, who can bring them up? If I'm having a super heavy pack for the automotive, what would be the negative impact? Yes. High energy consumption. How about, what else? Who else can add more, because there are a lot of more factors to discuss? If I'm having a heavy vehicle, definitely it will impact the dynamic. Definitely, speed is going to be impacted. How about that? As speed is impacted, high energy consumption. What else? Cost is impacted. Troubleshooting is impacted. If I'm having it a larger pack, definitely trouble means I'm having too many unnecessary batteries or low quality batteries. That's why I'm using too many cells, or I would say modules, in order to come up to that certain level of energy. Therefore, cost is impacted, troubleshooting is impacted, quality is impacted. So it's really important to pick the right one, the lighter one, the one that has more durability, more safety, and stability, and so many other factors. So far, everyone okay? Any question? Good? So, before I move from this slide, I'm gonna introduce another super important skills or expertise in battery design called BMS. BMS stands for Battery Management System. And S is system. What's the role of battery management system? In fact, although so far we were discussing about whatever is going on inside the battery to generate those like power, or let's say energy, which is a product of the chemical reaction inside the battery. Now we have to be able to maintain the state of health, the state of charge, the state of discharge of the battery, and more, a state of life or cycle, or everything about the battery. In order to do so, now is the time that we have to be a bit more expert in electrical design, right? Or control design, because we have to design a system. That's why we call it management. We have to design a system in order to be able to not to only control the damage of the battery through the battery management system and apply more safety to the functionality of the battery, and still be able to at any time look at the status of the battery. Like, for example, how many cycles the battery is going through, for how long more I'm going to have the battery, how much of the battery has been already used, means a state of charge or a state of discharge. A state of health means, is it going to be overused, too much of chemical reaction or no, and so on. Therefore, in order to monitor, not only monitor and control all of this, I need to design a controller. Therefore, battery management system is a controller, right? Most of the time, you can go ahead for some small project, purchase maybe one out of the, like one which is available at the market, and bring it and use it, especially for your capstone project. Or another topic for capstone project could be designing the actual battery management system, because there are a lot of research going on this field, being able to design the most efficient battery management system. In one of my postdoc projects, I was focused on designing a battery management system in-house. I was doing it in CMHT right in here, because that's very important. Many PhD students, many PDF researcher, postdoctoral researcher, and many other like faculties or researchers in industry, they are focused only on improving battery management system. It's that much important. And of course, thermal management is going to be monitored through the battery management system. So remember, we were discussing CAN communication in the previous lectures. One of the features that it can improve the quality of that battery management system is being able to just collect some information through CAN communication. So far, so good? Everyone clear? So next is going to be about lead acid batteries. Well, remember at the beginning in the very first slide, I said lead acid is a still secondary battery, means it is rechargeable battery, and it's one of the most common batteries in like vehicles right now out there, right? Therefore, it's good to learn about the structure of the lead acid battery. Well, lead acid has 3 layers. It has like the positive, negative, and what you can see in here, we call it electrolyte, or we call it separator. In fact, separator, as the name may introduce, has a role to avoid any short between the positive and negative, right? It's going to help to be able to pass the electron from one layer to another layer safely without having any disruption in the system. So electrolyte in here, it could be salt and water, or it could be, for example, other like acid solution. So it could be a combination of water or any type of acid solution, right? So it could be different material based on the application. Positive electrode, what you see in here, it has lead oxide, Pb, right? And O2 oxide. Lead oxide, I'm gonna write it. This one has lead oxide. And then what you have in here is going to be your separator to prevent, as I said, electrical short circuiting inside the battery and be able to pass the electrons from here to here. And if it is like backward, from charge to discharge, or from discharge to charge safely. Therefore, this one has like material to go around all these blue materials right in here. And this whole electrodes, positive and negative, are enclosed inside it. So again, it might be many layers, not only one layer of positive and negative inside this solution. Let's even call it solution, because most of the time this is a liquid, right? This is not solid. So in here, this solution is 64% water and 36% sulfuric acid, SO4H2, sulfuric acid. This is what this solution is being built of. Well, another important factor which I'm going to bring it to your attention, negative in lead acid, is a porous electrode. Porous means some spongy form of material which has like little holes inside it. And those holes inside it, it will kind of make it easier for the electron to be connected. So that's why we say it has like a spongy characteristics. It can absorb them and it can just ease the process of charge and discharge. That's why we say negative is a porous, or less is a spongy format or porous lead. But not the positive. Just negative has such a characteristics. Another type that let's say term that I'm gonna introduce is SLI battery. SLI battery is the same as lead acid battery. S in here stands for starting, lighting, ignition. That's why I say this part of the battery is the best option for automotive application. And as I said, since the material inside here is gonna just have like a quick chemical reaction, therefore the discharge and charge is happening faster than supposed lithium-ion battery. That's why this guy is not a good option for you to be used for your cell phone application, right? It may not even at some point be safe in order to use it for cell phone or any other smaller application. They are rechargeable, but they are used for that application that we need to pass a huge amount of current in a very short amount of time. So they can just pass a lot of current in a short amount of time. While we do not need such a let's say battery for cell phone. That's the reason. So if you need like lead acid battery to another factor, lead acid battery doesn't have this option to still be maybe half charge or maybe 10% charge or 20% charge and still be able to give you enough amount of power or enough amount of energy. While with your lithium-ion battery in your cell phone, even if you have 5% charge, still you can get full functionality of the cell phone, maybe for a shorter amount of time, but you get the full functionality of the cell phone, because even that 5%, it won't impact the chemical reaction inside it. You have it for a less amount of time, but still it does the job. It will generate enough power for you. But about lead acid battery, it's not like that. You have to have it fully charged in order to be able to get the 12 volts. If it is, let's say 10 to 12%, 10 to 20 or whatever percentage less than 100%, it won't be able to generate 12 volts, even for a shorter amount of time. That's another reason this guy is the best option only for automotive application, right? Any questions so far? Another one which I'm gonna explain is still lead acid, but as I mentioned, also we have like multiple type of lithium ions. We do have also for lead acid, different type of lead acid. One of them that you can see right in here, we call it VRLA, means valve regulated lead acid. Why is that? Remember, we are talking about that chemical reaction, always the process going from charge to discharge or reverse process. Simply means there are situations that we are gonna make the process, anyway, this is a rechargeable battery. Make the process reverse means if it is recharge or if it is discharge. If it is discharged during the application, now we need to charge it. Therefore, the process is reversed. Now we have to find the source to charge. That's why when you are losing your battery, somebody is helping you to just maybe by connecting their battery, to again start your battery, you need to charge it. How do you charge it? We are going to have that a part of this lecture at the end as well. But tell me how. You are connecting it to somebody else's maybe like battery to start. And that's starting is happening. But you need to maintain some charge. How do you do that? In order to next time be able to again turn on your car or start your car. You have to drive for at least 15 to 30 minutes. If you are going to keep it safe to make sure after you turn off the car again, you're not going to call maybe a maintenance guy or maybe your friend or somebody else to come help you to connect your batteries together to start again. At least after the battery is started, you have to drive 15 to 30 minutes to have enough charge being stored inside the battery for next time, right? So now, if you are having like regulated lead acid batteries, during that reverse process, as the reverse process is not perfect, some gas will be generated. Therefore, that gas is a part which is dangerous. If it is going to be stored inside the battery while functional, it may cause explosion, right? Therefore, they are going to create some valve or ventilation system inside the battery to release that excess gas, which is a product of chemical reaction within the battery while the process is reversed. Make sense? That's why we call it VRLA. In order to keep it safe, we have to get rid of that excess gas through the valve or through the ventilation system, which is a built-in system inside the battery, not something externally, right? So now, the process, another thing, remember I said we have different material. Another type of batteries is AGM, and AGM has a huge difference with other batteries. AGM is absorbed glass mat. In fact, we call it gel cell. So in here, we are not going to have similar maybe material in order to build the battery. They are perfect choices for both motorcycles and automotive, but not the most common one. So, well, they also use it for off-grid solar panels as well. That's another application. Also in the wind, right? In wind also, or wind power installation, they could be used as an energy storage bank in there as well. So they are good type of batteries, but the thing is they are very thin. One of the most important thing, they are gel cell. We call them gel because the material inside is like jelly material, but they are really thin. And the other thing is this type of battery, they have like fiberglass within the construction of the battery. That's why we call them glass mats. So that fiberglass is going to be a plate between the layers, the cathode and anode layers, in order to absorb the acid through that gel, because there are acid inside it. Look at here, we have in here like the separator or electrolyte. We have the positive plate or anode, cathode, and then the container. The container is a different material, but the thing is in here still we have acid, and we need that acid to be absorbed through this glass, right? Therefore, fiberglass. Therefore, that's why we call them gel, and through that they are going to generate energy. So in fact, that's going to be their separator, which is fiber glass. That's why we call them AGM, absorb glass. And that like gel is going to absorb the acid in order to do the process of charge and discharge. Like maybe you can say very similar to what we have for the porous electrode. While we do have in those porous electrode type of the battery, we do have those tiny holes to absorb the electrons. In here, we do have it gel in order to help with the process of charge and discharge. Next is going to be about, this is exactly what I explained for the other two type of the battery, the way that the process of charge and discharge is happening. So for example, in here you can see electrolyte is a glass mat or like fiberglass right in here. And if it is charged, electron is supposed to move from positive to negative. If it is discharged, the process is reversed. And for the discharge, this is the process of discharge. And this is the process of charge, right? The direction of the electron movement. And always, like whatever we have in the electrolyte is going to make the process easier. So now, if we have it in here, porous electrode, everything is around the two electrodes. For the fiberglass is in between them. They are not covered, the entire layers here and here, they are not covered. Only here is the fiberglass. But if it is like those porous electrodes, this whole blue part means like all those liquid, they are covering the entire electrodes all around them, regardless of how many layers of electrode we have. So I'm gonna just pause right in here, give you a break, and then we will be back with the rest of the lecture in the second half of this session. So meanwhile, anyone who has any question, feel free to come see me. Otherwise, you are good to leave for some break, and then we can continue.